Okay, so good morning. Good afternoon to those in Manila or in the Philippines, and good morning to those in London. So welcome to this lecture workshop, which aims to demonstrate how methods from the digital humanities can be used to deepen our understanding of the inner workings of the Baybayin writing system. For our speaker, you probably no need to introduce him, but this is for today. We will have Ramon Guillermo. He received his BA and MA in Philippine Studies from the University of the Philippines in Diliman, and his PhD in Southeast Asian Studies from the University of Hamburg in Germany. So Bowman has been teaching at the Center for International Studies, CIS, at UP Diliman, and he also serves as a fellow of the UP Institute for Creative Writing. In 2017, he published 3 Baybayin studies with Maifel Baluga, Maricor Soriano, and Vernon Totanes. If anyone, if at SOAS we have a copy, if you're interested, it's a really good book. I think you will learn a lot from it as well. But here to talk more and I guess delve deeper into this topic is Bowman. So Bowman, over to you.
Good afternoon. I'm here to discuss a piece of software I wrote to help in the automated reading and interpretation of Baybayin texts in general. However, I will be using as an example the earliest book published in the Philippines. It's called the Doctrina Christiana from 1593. This is probably the longest historically attested Baybayin text in the Philippines. It is a biscript and bilingual text. That means that the text is in both Spanish and in Tagalog. At the same time, the Tagalog text has 2 versions, a Baybayin version and a version in the Latin alphabet. So it is a very interesting text to study in order to understand how Baybayin was written during the early years of the Spanish period. And perhaps this also reflects the way that Baybayin was written before the Spaniards published this book in 1593. So I will be using certain samples from this text. And what we have before us now is a sample, the beginning section of the Doctrina Christiana. One thing about the Baybayin is that a lot of scholars have said that it is very, very difficult to read because of certain supposedly lacking features of this script. So it is said to be deficient in certain ways, so that it is rather difficult to interpret. That's why we even have this kind of, we wrote this kind of software to help us read Baybayin. But it is not impossible to read. That's one thing that we should emphasize. It is difficult to read, but it is not impossible to read. And more so for people who lived in a culture and in a context which used this script. So we have here a sample of a continuous Baybayin text. It doesn't have any punctuation marks. We will be adding them later. But for the most part, this is how Baybayin looks. Now, they say that Baybayin is difficult to read because it doesn't have any way of representing independent consonants. That's one thing. So that a word, for example, like ba, that could be read in different ways depending on how you add the independent consonants. So, for example, it could be bas, it could be bag, it could also be baba. So it generates homographs because of this lack of independent consonants. At the same time, there is no way, there's no easy way to determine the start and the end of words for Baybayin texts, because as with most Asian writing systems, there is no space or indicator between words, and and also the thing is, uh, sentences. There's no such thing as a period to demarcate sentences in Baybayin. So if we were reading a Baybayin text, without any kind of punctuation, that is how it would look on the upper part of our image here. And if we were to convert all of these characters to Latin script, then we would be seeing the lower part of this image, right? So that I think that for us, the text below is the way a Baybayin reader would be able to see Baybayin text, because that's how they would be able to read the text directly. But for people who don't use Baybayin every day, it's easier for us to read it in Latin script. So that's how it would look like for a for us, So I think if you were to look at the text in the lower part of the image, you'll be able to identify certain words. Even, for example, the beginning is sumasapalataya, which for us would be sumasampalataya, to worship, right? And then you would see ako sa Diyos Ama. Yeah, so you can actually read certain parts of makagagawa sa lahat. Yeah, so lahat sa laha, so where we're automatically adding consonants there. Magagawa na langi na lupa sumasampalataya. So you can see that it requires the addition of independent consonants so that we can interpret this text. Also, um, uh, it so that when we're adding independent consonants, we're able to see also where the words start and end. But if you look at the middle of such a text, you feel lost. Like it's hard to interpret this text if you're just looking at the middle. You don't know where to start and where to end. There are no indicators where words start and end, and where sentences start and end. So it is quite confusing, right? It is difficult to make sense of if you, for example, look at the middle of such a of such a of such a text. But that's not the way it really looks like when it looks like in Baybayin, because in this case, I removed the specific punctuation mark which is used for Baybayin text. So I'm going to show you the punctuation mark. This is called the Danda, or a stick, that's in Sanskrit. As we know, the Baybayin script is a Indian-derived script, and its punctuation, the Danda, is borrowed directly from Indian scripts. So those two vertical lines, they indicate the Danda, right? And the Danda doesn't really stand for, it doesn't function in the same way as a period. We must emphasize this, or even a comma. It functions, its function is quite different, and I think this still has to be explored in depth, right? Because we can't really understand this kind of punctuation using the Western notions of punctuation. We have to understand this punctuation within this writing system and how it functions in this writing system. So if you look at this version of the text from the Trina Christiana with the Danda, of course, with the Danda, there's only one rule that's quite clear, that you can't place a Danda in the middle of a word. It has to be at the beginning or at the end of a word. So you can see here that if you look at this text, even in the middle, you will see that it's now easier to absorb and interpret, even though there are still difficulties because of, for example, we don't know the vocabulary, we don't know the orthography of the Tagalog that was used in the Doctrina Christiana of 1593. And yet, I think the Danda allows us to have an easier entry into understanding the text itself. So we can even, for example, pick out a segment, a Danda segment, Danda bounded segment. And for example, this one, makagagawa sa laha. So that will be for us automatically adding a T at the end of laha, then makagagawa sa lahat. Yes, so that's something. And then, for example, this namata, right? So this could be namatay, this could be namatay. Of course, it could be other things too, but given the context, it could mean namatay. So the Danda allows us an easier entry into any Baybayin text. You see, it doesn't mark out sentences. It sort of allows us to, process a Danda text in smaller chunks, in smaller pieces, so that we can interpret these pieces more easily, as opposed to having no Danda at all, which is very difficult to read, right? So this is a version with Danda punctuation. Now, after processing such a text, going through it, we can actually try to add. Here there's Danda punctuation, and we've added, according to our interpretation, the independent consonants. Also, we have tried to separate using a slash, right? To the to separate words with a slash. So, for example, let's look at the first part. Sumasampalataya aku, right? So you see here, sa Dios Ama, right? So this takes some processing, and now you're able to understand the text more easily. Now, another thing about the Baybayin script is that it neutralizes e and e, also o and u. Even though in Tagalog there may be differences in meaning when you change those vowels, but it is neutralized in Baybayin. So that's another thing that's a problem with they say with Baybayin. You have to interpret those things later on. Although here in this example, I did not um, differentiate between U and O or A and E, right? So for example, here in the last segment, we have ang mga santo, right? Well, I'm not sure how they said santo before, but if we interpret this today, then we would probably write santo. It's not santo, right? Look at this, for example, this one, Espiritu Santo. So here we also see another difficulty, supposedly with Baybayin, that there's no difference between R and D. So that Espiritu Santo becomes Espiritu Santo. This is a matter of processing and interpreting the text. And it is not, however, it may add a certain difficulty, but it is not impossible. For example, here, if you look at the middle, so with the Danda, everything is so much easier. Ipinako sa kudus, right? So you can, given the Catholic context, ipinako sa kudus, right? So you can already see here now that if you have a Danda, then it makes things easier. And this has not been remarked upon by other scholars of the Philippine writing system. No one has actually written a lot about the Danda, only a sentence or so that this is how a Danda looks. But not there have been no real studies about how the Danda functions in the Baybayin system. In my view, the Danda is a kind of complexity device for reducing complexity, so that we can more easily process these texts cognitively. Um, we have here certain statistics about the Doctrina Christiana text. Um, so we count the number of segments based on the number of dandas that it has also. So it has 607 segments. And what is the average segment length? So we can count the number of syllables per segment, and then we can get an average. That's 6.5 syllables, tending towards 7 syllables. If we just look at the word list of the Doctrina Christiana in terms of syllabic, in terms of its uh, syllabication, the raw syllables of each word, then we have 395 word types. And these word types repeat at different rates so that we have actually the total number of words is 1,812 words in the Doctrina Christiana. But the number of unique words are 395. These are the word types. Now, if we are able to distinguish homographs, for example, because a homograph, our syllabic word list, it has, for example, baba, but baba can be read in several ways. So it forms a homograph. So if we count also how homographs are later on differentiated into different words, then we have actually 444 unique words in the Doctrina Christiana and 1,812, the same number of word tokens. So the longest syllables, the longest segments, if we have an average of 6.5 syllables per segment, the longest segments are 19 syllables in the Doctrina Christiana. So we have here the actual images from this book, right? And this is actually these are the actual excerpts from this book. So if you look now at the at how those segments are distributed in terms of segments, price segment length, we can see how there is really a tendency towards having segments having only a length of 4 to 7 syllables, right? So 1, 2, 3 syllables. There aren't so many segments with 1, 2, or 3 syllables, and then we don't have really too many segments with, let's say, 9 to 20 or 9 to 19 syllables. The great majority of segments have a length of 4 to 7 syllables. And if you make an average, a running average of segment lengths, as we go along the text, right? So we see here is an average per 50 segments as we go along the text. We see that it is averaged, just around 6.5, as we go along the text. So there's a great degree of control here, in which the writer of the Baybayin text actually seems to ensure that the lengths do not exceed an average of 6.5 or 7 syllables per segment. Of course, this kind of control is not really conscious, because how can you really count the number of syllables per segment every time that you're writing a segment, and that you're actually making sure that you have an average of around 6.5 to 7. So it's almost impossible to do this consciously, but the Baybayin writer of the Doctrina Christiana seems to have had a great degree of control over the average lengths of the Baybayin segments. Yes, so now we go to the computer program, which we are going to discuss. And here we can see that the program tries to look for interpretations of each segment. So what you do is you just enter the raw syllables into the program, and the program accepts any segment length. It can even accept segment lengths which are much longer than what we have in the Baybayin text, in actual Baybayin texts, and it will still try to give an interpretation of these longer segments. But as you can see here, the computer takes a much longer time when the segments become longer and longer. For example, if you look at segments of length 1 syllable to 10, that's just around 0.26 seconds, right? So that's a kind of minimum. That's kind of minimum runtime. In fact, it looks like the minimum overhead runtime of the program itself. But once you exceed 10 syllables, you will see that the time required for the computer to process to produce the first result increases exponentially. So that, for example, a segment length of around 27 or 27 syllables will require around 1,000 seconds, which is around 16.6 minutes, right? So that's a great difference. 16 over 16 minutes is a great difference from 0.26 seconds, right? So apparently the longer the length of each segment is, the more difficult it is for a computer to process and try to produce a result, an interpretation of these segments. So it's very much like, I think, the human brain in that respect. Right. So for example, we have here a segment length, which is purely hypothetical one, which does not actually exist in the Doctrina Christiana, but was just taken from the Doctrina Christiana. So it's a segment length of 29 syllables. It took 27.83 minutes. In our particular run of this program required 27.83 minutes to produce a result, right? So the result is, sumasampalataya ako sa Diyos Ama, makagagawa sa lahat, manggagawa ng langit, right? So you can see the difference between how manggagawa is used today, and manggagawa probably was used, the creator, in the Doctrina Christiana. So I'll be explaining this in the next part, how the program actually works.
Okay, so can you see the new screen?
Yes, we can.
Okay.
The Jupiter,
so
yeah.
Yeah, so this is a Baybayin reader, and it's special. At the moment, it's specially designed to read the Doctrina Christiana. So what it does is you feed it syllable sequences, and it tries to figure out how to read that, right? So I'm going to explain it a bit. This program is written in Python. So I think Christina knows a lot about Python, and it's this interface is the Jupyter interface, because it allows us to look at how the program works. You don't have to. We're not just facing a blank screen. We're looking at how it's working. So it's easier for us to understand what's going on. So this program is designed to allow us to try to process Baybayin text, to try to read sequences of characters line per line, right? So how does it work, right? So okay, so very quickly, first the user of this program. I'm sorry because it's it's magulo, because I haven't really fixed make it look good, this program, but it's rather magulo ngayon. So sorry about that, but I'll fix it up so it looks better. if you want to use it yourself, right? At the moment, you can set certain parameters. For example, itera, that's set now for for 1 million. That itera is iterations, right? So iterations is set it at so that means that how many iterations is the program going to do to find what it's supposed to find, to read the Baybayin text, just to sort of just to sort of set a limit, so that it will stop at some point, right? In reading that text. So it's now set at 1 million. It can be more, it can be less. It doesn't have to be 1 million. Actually, this is a very high value for iterations. So you're just setting it there so that you will you're just telling the program that you can go. If you haven't found it yet by a million tries, then stop. Right. So now you have break if found. This break if found, this value, if you put it at 0, then it will continue looking for readings of the Baybayin text or sequence until it goes into the 1 millionth iteration, until it goes to the value that we set for iteration, right? Which is set to 1 million at the moment, it can be 5,000. Now, if it's set at 0, if break if found is set at 1, sorry, that means that if it finds a reading, a valid reading of the sequence, then it will stop. It will stop the program. So is that clear? That well, so I'm setting at 1 now, so it will stop once it finds a reading of a particular Baybayin sequence. And so we have here a certain Baybayin. So now we're not reading here directly Baybayin characters. These are transliterated into the Roman alphabet because Python doesn't really accept at the moment Baybayin characters, right? So that's difficult. Maybe I'll figure it out later. But at the moment, it's harder to make it accept Baybayin characters. So now we're just using pseudo Baybayin, right? Sequences of characters which follow the sequences in the Baybayin text. So we have different lengths here. I have these are the sample texts which we will try to read using this program, right? So we have 1 to 6, length 1 to 6, and length 7, 8, 9, yeah, up to length 19, and also a length 29, which is just something I invented, but it's also derived from the Doctrina Cristiana to see if it can still read even a line that's 29 characters long. And then we can even make our original sentences like this one that it will also try to read, which is original sentences which are not in the Doctrina Cristiana. So what does it need to run? It needs a dictionary, right? So it needs a dictionary which is appropriate to the Baybayin text you want to process. So at the moment, we have a dictionary that is derived from the Doctrina Cristiana. Yeah. So here is the, I think. So it's a dictionary which is syllabic, but it has a transliteration and possible readings. That is so you can already see you can use it to translate the reading into more readable Tagalog, right? So this is a whole dictionary. So that's one thing about this. One thing about this program is that you have to make dictionaries. Now, if you have a whole Tagalog dictionary that you can input here, actually it doesn't have to be directly in the program. It can be in another file. But if you have a dictionary that is Tagalog and then you write in Baybayin only and you have Dandas, I think this program can read it even if it's not the Doctrina Cristiana. But the Tagalog of the Doctrina Cristiana is different from the Tagalog today. So if you use modern Tagalog dictionary to read by Doctrina Cristiana, it will not work because the dictionary must match the era and the type of language that is being processed. So it's hard for it to using a 21st century dictionary. You can't actually read a 16th century text, right? Although it's very surprising in my research that the Tagalog of the Doctrina Cristiana is still very close to the Tagalog that we have today, right? So it's a very stable language. So that's one thing that you have to worry about. It's having this whole dictionary. Now I'm just going to go along, try to explain how it works. Oh no, I have to clear this because there's something that they processed. I'm just going to clear output. Okay, so okay, so what it does is yeah. So what it does is that it um, it determines how long that segment is which you want to process, and then it looks for all the words which can be found in that sequence. Given that there are many homographs, or that there are many words which are written the same in Baybayin, right? So, for example, uh, um, uh, Paypay, for example, is just papa, so it can mean many things, right? Pampang and other Tagalog words, right? So given that there are many homographs, it tries to find how many word forms in the dictionary can be found in that sequence, in that segment that we are sending to it, right? And then when it finds all the words, possible words that can be found in it, it tries to fit them like it's a jigsaw puzzle. It tries to fit all of these words into that sequence, following the lengths of the words and their placements in the segment. It tries to fit. It tries all. It tries all of the ways by which you can fit these jigsaw puzzles into, so that it can find a possible reading. This is just a possible reading, because there are also many possible ways by which that the jigsaw puzzle, at least in this case, can be solved. But it can find all possible solutions. If you give it enough time, it will find all possible ways that the words fit with each other in that segment. And there's an error crap here. This error crap means that if it finds that there are words in the segment which it does not know because it's not in the dictionary, it will tell you, no, I don't know this word because it's not in the dictionary. So you will immediately know that you have to stop the process, because it's not going to be able to find any valid reading, because the dictionary is not complete, or is not appropriate for that segment, right? So, and then what else? So I'm going to run it first, so you can see how it works. I'm going to go for a um, an average length Baybayin segment, which is 7. Now, this is a bit longer than the average 6.5, but 7 is all right. Yeah? So no, let's try this one. Okay, right. So maybe you can even read it in yourself, even now, right? So let's see. Let's run this. Oops, what happened here? Wait a minute. I have to restart it. Okay. Oh no, I think I set the iterations. Sorry. I think there's a bit of a problem. Oh no, what happened here? Let's see. Ryan copies. Aha, this is it. Sorry, I had a problem. I was accidentally running a 19 syllable segment. That's why it was taking a bit long. So now let's go for the 7 syllable segment. Hey, so now, okay, so I ran here, you can see at the top, what was I trying to assign it to read? Baya ka happy happy, right? Yeah, so that's the syllable sequence, right? And that can easily be translated to Baybayin. And we go down, right? So and then it says, okay, sorry. Okay, so it says here, it found three words in this sequence. Baya, ka happy happy, right? So it found three words. So now here it shows us that all of the parts of this segment, they're filled up. That means it's an X, sort of it'll be zero if that section or if that syllable does not have any word or sequence of baybayin connected or assigned to it. That means that the dictionary is incomplete. This shows us that the dictionary is complete because it's all X. Then it tries to process it and it gives us a reading. So what is the reading of this text? Bayang, bayang, kahapis-hapis, or miserable nation, right? And it was able to read this text, this short segment, in 0.28 seconds, or in almost a fourth of a second. So, so that's how I think it would work for almost all segments which are seven characters long. So let's go and do another seven segment, a 7 character long segment. So let's go for this one. Uh, let's go for this one, right? Anakata ata wu, right? So let's go for this. Let's try to read it. So we have very quickly a solution. You see, so look, it says this is not the correct reading, but it is a possible reading because it says ang na katawan tao, right? So it was able to do this in 0.28 seconds. It is not really the correct reading. So what I will do is that I will change the settings so we will be able to find the correct reading. So I will set the iterations to 5,000, very low number, and then set the break if found to 0. So that it will go through 5,000 tries to find that solution. All right, so here it is. It found three solutions in 1.6 seconds. So which one do you think is the more correct solution? Let's look at the first one. Ang nagkatawan tao. Ang nagkatawan tao. So si Kristo ang nagkatawan tao. So you can see that this is probably the correct reading, the first one. Si Kristo ang nagkatawan tao. He assumed the form, human form, right? And the others, the two other readings, they are possible readings. At least in this jigsaw puzzle where it's trying to fit words into each other. For example, since the first two syllables are ana, it says, I think we can read those first two syllables as anak. Yeah, so it says anak, katawan, tao, right? But that doesn't really make sense, no? So although it is a valid reading based on the syllable sequence, it is not the correct reading. So what the feature of this program is that it allows you to go through all possible readings so that it will show you the correct one, right? So from 7, maybe we can go to a longer segment. Maybe we can go to double the length. Let's say 14, right? So this will take a bit longer than the 7 character segment, right? So I'm going to run it again. Sorry. Are you following me?
Yeah. For me,
Okay.
yes. Yeah,
Yeah.
it's very great. Thanks.
Okay. So okay, um, let's go to the syllable length, which is 14 characters. So let's try that out. It's double the length of 7. So we'll just run it. It's taking a bit longer, right? But it came up with something in 4.5 seconds, right? So what does it say? Ito, well, so if you look at the two possible readings it throws at us, I think the second one is the correct one. Sa nabubuhay at sa nangamatay ng tao, right? So this is talking about what will happen, you know, uh, I think when when what you call, when the final judgment comes, you know. So this happens, you know, that it happens for the nabubuhay, for those who are living, and those who are dead, right? So a possible reading which it throws at us is sa nabubuhay at sa nangamatay na tao, right? So this second reading is, I think, the more correct reading. And you might say, you know, this is still a problem because, you know, it's throwing at so many readings, right? But actually, these are only very limited. It can only produce a very limited number of readings per syllable segment, because there is the constraint of the syllable itself, of the syllable sequence itself, and its length, and the constraint of the dictionary. So, given these two very strong constraints, it can actually produce an infinite number of possibilities of readings. So there will be some readings which may, I think, which maybe there may be some syllable lengths which may produce quite a number of readings, but not very many. So in this case, we found that it's very easy for the program to actually read even a 14 syllable segment. Uh, it took only 4.5 seconds to get 2 readings from this 14 syllable segment and to produce what is possibly the correct reading. And now the main thing which makes it which makes reading, you know, you notice that the longer the segment is, the longer also the time necessary for the program to process it. It's not actually only the length of the segment which matters, but actually the number of words which are found in that segment. In this case, there are 13 words which it found in that segment. 13 possible words. So that's not, that means there are only 13 possible words, and it tries to fit all of these 13 possible words into different configurations of reading so that it can throw it to you. But the more possible word, the more word forms there are which are found in a segment, the longer it will take for the program to process. So you can imagine there will be long syllable sequences with few word forms. It's possible. It's quite possible for that to exist. But so that will take a very quick. It will be very quick to process that. But there will also be very long syllable sequences which have very many word forms, and that means it will take much longer to process. So let's look at the word forms here. So the 13 word forms are here. It found all of the word forms which can be read in that segment, and then it tries, like a jigsaw puzzle, tries to fit them all together, and it produces those results, right? So now let's try a longer, even an even longer segment, right? So we're experimenting here. Let's try a segment that is uh, 19, 19 syllables long, right? I hope this doesn't take a very long time to process, right? So I'll just set the iterations to a higher value because that's I'm going to set it at 20,000, and I'm going to set break if found to 1, so that if it finds a reading, it will throw it at us, right, immediately. So bear with me if this doesn't take, if this takes a bit longer than the other ones. So it's 19 characters long, right? That's the longest in the Doctrina Christiana. Yeah, so it was able to find a solution after 3.5 seconds. In fact, that's even faster than the other one, right? But this is probably not the correct reading, right? Because um, na mata this is ating Panginoon, right? That's correct. Ating Panginoon Sisu Kitu. That's correct, right? Ating Panginoon Jesu Kristo sa kudu, on the cross. So at our Lord Jesus Christ on the cross. But the first few syllables, they don't seem to make a lot of sense. Na mata na. So ating, actually this from here, ang ating Panginoong sisukitu sa krus. That already makes a lot of sense. But the previous syllables apparently don't make any sense. So can I try to find, set it so that it can find the correct solution? So let's try to, I'm just going to set it at 10,000. So it's going to take a bit longer. Sorry about this, but maybe maybe we'll able to maybe we will be able to find it. Maybe not. And let's just wait a bit. Yeah, so you can already see, this is my point here, that if for the computer, it gets more and more difficult for it to process longer and longer. So it was not, look at this, so here, it found 19, look, that's a lot of word forms in that syllable, syllable sequence, right? It found 19. And all these words, if you combine them properly, actually will give you the right reading. But it ended just like that with no solution after 15.9 seconds because it was not able to find any solution given the low value I set for iterations.
But
right?
you set it to 0, eh? No?
No, I set break if found to 0. That means, look, iterations is at the moment 10,000, right?
Uh-huh.
Break if found is 0. Now, break if found means if I set break if found to 0, that means that it will not stop. It will continue going through all the iterations until it reaches 10,000. If I set break if found to 1, then it will stop once it finds a reading, a valid or a possible reading.
Okay.
Right? That's how it works, right? Now, I'll try to set it at, if you can wait a bit, I can try to set it at 20,000 because it's embarrassing that it's not producing any result at the moment, right? So can I try it, right? Let's try it. If it doesn't work, then I'll just go to another topic, right? So, yeah. So the point here is that if it takes the computer longer to solve longer character sequences in Baybayin, and it's much quicker when it's short, actually 7 characters long, then that's the same for the human brain. Yeah? So the problem with long syllable segments is that our cognitive abilities are not really up to. Oh, so it even ended without any solution at this time. So that means I have to set iterations at a higher value, which means it'll take a longer time. But it's funny that it was able to give us a solution earlier on, right? Although even though that solution was not the correct one. Now, why does it not give us a solution even if it takes a longer time? Now, of course, it will give us a solution if I set it at a high enough value, and all of the possible solutions. It's just that we don't have any time to do that at the moment. Even the, why does it give us a solution? Even when earlier it gave us a solution, it's because that this program, because there are so many unknowns it faces. It doesn't know how many words there are in a segment um, from the beginning. And if you don't know how many words there are in a segment, you have to try to combine all of these words together. You don't even know how how many permutations you have to go through in order to solve it. So it follows what is called in statistics a random walk. It walks through the possible combinations and it tries to find one in a kind of random pattern. Uh, but statistically, it still conforms to averages. Um, because if it's a short syllable sequence, generally the solutions will take a shorter time to find, but it will take a shorter time to find. But a longer segment, it will take longer. Sometimes it takes such a long time to find. I will show you the statistical results later on. But I just want to run another example. Sorry about that. I was not lucky enough for it to find a solution for the 19 syllable segment at the moment. But I will run now a Baybayin segment which I just made up, so that you will see that it even reads stuff that you make up yourself, and it's not in the Doctrina Christiana. So this Baybayin segment is uh, Manaka Casa Ilicia, right? So that's it in Baybayin, right? Or in pseudo Baybayin. Let's run it. Sorry, I'll just set it to a lower value, this one, and set it to 1. Right. Yeah, so, okay, so it found two readings for that. So it found two readings for that made up text. So this is the correct one. Magnakaw ka sa iglesia. Magnakaw ka sa simbahan, right? Of course, that will not be in the Doctrina Christiana, right? But it can read even texts which you make up, but in that language, of course, of the Doctrina Christiana. So for the vast majority of the segments, which are seven segments and below, this program very quickly solves or finds solutions for them. And I'll show you the averages now, right? So I'll just share another.
Bowman, there's a question from
Okay.
Nico, just quickly. How did you input the dictionary in the Jupyter interface for the Baybayin?
Okay.
Did
So
you do
there's
it manually though, or online resource?
no. There's no online dictionary for the Doctrina Christiana. So, well, when I wrote my book about with a chapter on the Doctrina Christiana, I was able, luckily, to have written down, to have had that dictionary, to have made it when I was writing my earlier study, which did not use this technique at the time. So I have a dictionary because I was doing another research using another method when I was writing the book. So I didn't get it from any other resource. Now, to input it into Jupyter, of course, there are two ways. You can input it directly into the interface, and I did that so that you can see that the dictionary is there. But Jupyter can also read it from a file. So that's another thing. And the Python works with the so-called dictionary types of data, and this dictionary types of these kinds of data, which are structured like a dictionary, is very, very appropriate for these kinds of analyses. So so that's a question. Well, I did it manually, that dictionary for some years ago when I was writing the study on the Doctrina Christiana. I did have a dictionary for that. Right. So next, how do United States set to 1 million or make it found to 1 or 0? So that's a question. So what you do is you estimate. For example, if it's a 7-syllable segment, you probably need just 5,000 iterations to find all possible readings. And so you set the break if found to 0 so that it won't stop when it finds one solution. It can find 3 solutions or 4 solutions within 5,000 iterations. So it's still exploratory. How many iterations you would need to be able to read segments of a particular length, right? But if it's very long, let's say if it exceeds even 20 characters, then you have to experiment. It's not very easy, and it's a rule of thumb maybe to find whether you need a million or something iterations to find solutions to that. So it's actually very, very flexible. You just set it and try to find out what works. Yeah, so you don't have to wait for a million. You start with the lower figure. Don't start with 1 million immediately, because that's quite a long time, right? Processing, right? So at least those are the questions at the moment, right? So I'll now show you um, how long it takes for it to solve. So this below you have the x axis, which shows you the number of characters in that segment. And then you have here on the y-axis the number of seconds necessary to solve it, right? So you see that the amount of time necessary to process longer and longer segments increases, I think, at a very fast rate. Now, what I did was that I averaged 10 readings of for example, each data point here is an average of for example, here we have data point a segment length of 1, right? So this segment length of 1, we ran it 10 times and got the average time necessary to find the first solution to it. And then we go to the second, and then we have this is the second, 2 segments long, 2 characters long, and then we found we ran it 10 times and found the average time necessary to find the solution. So you can see here from 1 to 10, you will see that it's actually almost constant. It's not really constant, but at least from 1 to 7 or 6, it's 0.25 seconds. So if you need 0.25 seconds to solve a 1-character segment, that means that's the minimum overhead for running this program, the minimum overhead. So amazingly, our Tagalog forefathers, knew that up to the 7th, up to a length of 7 characters, we are running at the average or the minimum overhead necessary to process it, right? Process and parse that segment. But after 7, and there will be increases, and very large increases eventually of the necessary amount of time to process it. So here we are now going to, if you have a segment of 29 characters, then that will require sometimes more than 1,000 seconds to solve, right? So that's a lot, 1,000 seconds for a 19-character segment, whereas you need only 0.25 seconds to solve segments which are 7 characters and below. So you can see here how efficient the process is by which the Danda allows a reader, given the increasing cognitive burden of a longer and longer segment, how Danda allows a reader the capacity to read these medium or very short length segments. And it goes appreciably higher, very much higher, as the segment lengths increase. So this is just a measurement of the benchmark for average computer run times, right? So this is different. I'm not saying that it's the same as human beings, right? It's not the same. Obviously, human brains work differently. Obviously, humans have access to semantics and other things that computers don't. But I'm just saying that it's comparable to a certain extent that this is only a measure of complexity, a kind of rough measure of complexity as segments get longer and longer. And this is a kind of baseline complexity which human readers of Baybayin will have to face, regardless of their other capacities or intuitive capacities. So um, um, early missionaries and uh, and friars who observed Tagalog readers of Baybayin, they saw that Tagalog readers read Baybayin text very quickly, right, with no errors. That's because of the Danda system, because they kept the Baybayin texts within bounds of uh, reason that they are able to read uh, these lengths. Okay, so now, let's go back to Christina's question earlier about possible connections, for example, more historical or let's say geographic considerations. So it's always been asked, where did the Baybayin system come from? No? So, the scholars of Philippine writing systems, they've always said, maybe it came from Sumatra, or it came from Java, or it came from Sulawesi, right? So I think looking at the Danda and how it operates, you can already see which writing system in Indonesia it sort of more similar to. It is sort of more similar to. So let's look at the different. Oh, sorry. This is a result for a segment length of 29, which is a very long segment. It's just a made-up segment because it doesn't exist in Doctrina Christiana. It took 27.83 minutes to solve. So sumasampalataya ako sa Diyos, Ama, makagagawa sa lahat, manggagawa ng langit. So it's able to say, but it took such a long time to solve this one, right? Don't have that kind of time. So now let's go to the different writing systems in near our country. So this is our system this is called Surat Batak, right? This is found in Sumatra, in Indonesia. Then you have here the Surat Bugis and the Surat Makassar. These are old writing systems. Surat Bugis also here. You see, the Surat Bugis, it has a Danda, right? Those three dots. Surat Makassar also has a Danda, three vertical dashes, right? Now, now these are Indic scripts also, and they are found in Indonesia. And now this Batak script, it can represent independent consonants, and you will notice it does not have a Danda. Now the Bugis script, it cannot represent independent consonants, and there are no spaces between words, and it has a Danda. And sometimes the segment lengths in Bugis also get very long. But the average for some of the Bugis texts I've looked at, the average length of segment length for Bugis text is just five characters. Then you have the Makassar system, which is also cannot represent independent consonants, and it has also Danda. So if you look at this as a system, a logical system, which operates to allow us to read text more easily, then the Philippine scripts are more closely related to Sulawesi systems, right? Because they have this complex integrated mechanism which allows complexity reduction by means of Danda. Now let's look at the Ambahan poem, in Mindoro here. This is not Baybayin, this is Surat Mangyan, and of the Hanunuo type. And you can see that it has Danda, right? Those two vertical lines slanted a bit. This was written by Postma, the Dutch scholar. And now the thing about Ambahan is, or this poetry of the Mangyan is, and the great majority of these texts written in Surat Mangyan, their Ambahan, they maintain a very rigid rule in terms of Danda usage, which means only 7 characters. 7 characters. It's always 7 characters. So that means that if you look at the computer simulations which we did, that it still maintains itself within that reasonable length of 7 syllables, which are highly readable for a reader who knows that language and what is being talked about. So the Mangyan system represents a living script, which still uses this highly integrated system of punctuation and combined with certain quirks. This is a readable uh, system which the Mangyan use. So I will be having another lecture, I think, in September, and I will demonstrate there how this program can be used to read Mangyan Ambahan poetry and other Mangyan scripts. So that's with the I think with the archaeological studies program in UP. I will be having that discussion. I will demonstrate how Mangyan scripts, which seems very odd to us and unreadable, can be read automatically using the program which I demonstrated today. I think um, now another thing that I want to emphasize here is that if you compare the Baybayin script to the Bugis script over here and the Makassar script from Sulawesi, you will see that the Baybayin script is much closer in shape and form to Indic scripts, to um, to the Indian systems, and that probably means that the Baybayin system is a bit older than the Bugis script and the Makassar script. And if there was a common ancestor somewhere in another island, then that's something that is still to be explored. So um, I think this is a reasonable hypothesis as to which writing systems in Southeast Asia our scripts are more related to, you know, and and this was done because we were looking at punctuation, and the thing is, no one looked at the punctuation of these writing systems before. If you look at all of the books that have been written about the Baybayin, about the Mangyan writing system, no one has discussed punctuation. And yet, punctuation is central to understanding this writing system and where it came from and its history. So, thank you very much.
Thank you, Bowman. That was great. Um, can you, I just had a quick question. Can you explain the idea of the vowel killer
Okay.
idea?
So, uh, let's go back to the first one, right? So, let's say if you go here at the bottom, right, you have suma sa palataya. Now, if you know Tagalog, that means suma sam palataya, right? Sam. So here, there is no indication that there is an M or a nang or a nga there. It just says suma sa palataya. Now, if you have a vowel killer, you can actually put nga, nga down here or M, right? For example, let's say M. This is M. And then you can put a vowel killer below M. For example, the cross, which the Spaniards invented. And that means that you have to read the M without without any of the vowels that it comes with. So if you write just the M in Baybayin, that's ma. And if you have it with the kudlit at the top, then that's me. If you have the kudlit at the bottom, that's mo. But there's no way to write it in a way that there is no succeeding vowel. But if you have a vowel killer and you included that with the character, then that means you can read it alone. So suma sampalataya, that means you can. But if you put just the character of the Baybayin there without the vowel killer, you can read suma samapalataya, which is not correct and even more confusing. So um, that's how a vowel killer functions. It allows us to actually more easily and more accurately transcribe the sounds of words into a writing system. But lacking that mechanism, which also the Bugis system and the Makassar systems lack, uh, uh, the Tagalog and others who use this kind of script, who use this kind of script, invented the way that the Danda is used, so that it can allow us to actually read it even without uh, recourse to a vowel killer.
A follow-up question from Mark Bowman. Why do you think that the folks in the past didn't add a vowel killer before the Spanish did?
Well, yeah, that's a big that's a big question, yeah, because other scripts that that we may have, for example, had knowledge of. For example, the Laguna copper plate, that has a vowel killer in it. That's in Kawi. That's in a Sanskrit writing system that was used in Indonesia, and that has a vowel killer. So there we were, there were systems with vowel killers in nearby islands. For example, in Sumatra, uh, the Surat Batak also had vowel killers. But I think it's a matter of historical accident that the perhaps the, um, the mother script or the ancestor script of the Baybayin probably had no vowel killer, and yet it had this complex Danda system, so that the users of this script did not find it necessary to, include vowel killers, because given the Danda system, they could actually already read with ease what they were writing, given their purposes. So it's also a matter of need. Maybe they were already writing using this complex system of complexity reduction, and they felt they did not need that vowel killer anymore. And it's the same with the Bugis, Sulawesi. In Sulawesi, the island just below Mindanao, in fact, the Ila Galigo, that's the longest written epic in the world. Ila Galigo is written in Bugis script, which does not have a vowel killer. That's the longest written epic in the world, in Sulawesi, just below Mindanao, written in a script which is, in terms of Danda usage, highly related to the Baybayin. So it did not, for them, represent any insurmountable difficulty in reading. How would they be able to write even the longest epic in the world without a vowel killer? I mean, that's for us, for example, maybe that's uh, unbelievable, but things work according to what people think they need. And I think the Bugis thought that they didn't need any vowel killers. They had a good enough system, and it was working. Also, the Tagalogs probably thought, you don't need those vowel killers. They just make things more, messy. So they had their own system, and it worked for them. So that they didn't feel any need for those, even if they were aware that there were other systems with vowel killers.
So what do you think was the role of memory in the sort of, was it spontaneously read, like if there was a bye in text, was there some kind of context for what?
Yeah.
Yeah.
Uh, yeah, if you look at all the living writing systems in Southeast Asia, in at least in the Philippines and Indonesia, if you look at Surat Mangyan and Banwa, also the many writing systems in Sumatra, and also in Sulawesi, you would see that reading these scripts require a context, a cultural context. It requires that you sort of are immersed in that context, that that you have what is called a feel for the language. In German, Sprachgefühl, Sprachgefühl. You feel the language so that you can form sentences easily. And if you're a foreigner and you're looking at these syllable sequences, and you don't have any context, any kind of, let's say, even ritual context, or a cultural context that you need to understand them, then it's hard for you to fathom it. And that's why, for example, the Kalatagan pot is such a difficult puzzle for archaeologists, in the Philippines, because there's no context, there's no clear context for it, right? So it's very hard to read. It's all we have are sort of hypotheses. We don't really have a lot of things to go on when we're reading those kinds of decontextualized objects. So reading these kinds of scripts also requires context. So it's also wrong for us to think that let's use this computer, let's run these programs. It's gonna read everything for us. We're not gonna need any. We're not gonna need the context or those people anymore. No, it's quite wrong
Yeah.
to think
Yeah.
that, because even developing the dictionaries for these kinds of automated things requires a knowledge of the context, and to show the output, for example, to a native uh, speaker, and then to ask him or her which is the correct reading. The computer produced 5 different readings. Which one is the correct one, right? So that you have to ask that to the person who knows the context of these texts. So there's also memory, as you mentioned. There's memory involved, a lot of
Mm,
memory and context that's involved. Without memory, um, it's hard to read these texts intuitively.
mm,
But it was also necessary for them to develop a way to make it easier.
mhm.
So if you're looking
I
at a
see.
Baybayin text that has no danda, then
Mm,
even with memory, even with context, it's so hard to read it. But
mm,
with
mm.
memory and context, and with danda, you can actually, I think, um, have a good prospect of reading text in that community.
So Timothy is asking, this program clearly shows that, I guess the computer program clearly shows that combinations of characters can have multiple meanings. Is it possible that ancient writers used this to their advantage, conjuring multiple simultaneous meanings? Or did they want precision in meaning? Or do you think there was an advantage to having this kind of or would you say there were possible meanings that they wanted to conjure, or what do you think?
Well, there are constraints to reading things. Uh, Even Umberto Eco said that there are limits to interpretation, right? Um, obviously, yeah, I think that the computer shows us that there are many possible readings. But the problem is with many of the readings, it's not grammatical, right? So it's not grammatical, and the semantics are maybe wrong, right? So the syntax and the semantics don't work because we're not loading the computer with syntax and semantics. In the future, when someone develops a version of this program using AI, then it's possible to input a bit of syntax and semantics in there, but so that the range of reading will be even more constricted or constrained. But at this moment, this program doesn't work with any syntax or semantics. Therefore, it produces what may be nonsensical readings, even for someone who can read the text, right? So read that language. For example, in my experience, ambahan poetry, uh, uh, it's a very highly structured and very what do you call this? Very um, I wouldn't say formulaic, but it's it has its own kind of idiom. The ambahan poetry, meaning that um, an ambahan poet would immediately know, for example, that this is what this this sequence of characters seem to be saying, and would say, no, that's not the right reading. For example, I was in Mindoro one time, and then I had a Mangyan poet. I met a Mangyan poet, and I said, hey, just recite your ambahan. I'm going to write it in ambahan script. So he
Mm,
began reciting, and I began writing his um, his recitation in Mangyan, Surat Mangyan. And then he at a certain point, I made an error in transcribing his poem, and then he corrected me immediately, my
mm,
hand immediately, and then wrote it himself. Uh, Wrote the
mm,
next parts himself. That was a very nice piece of paper which had a bad
mhm.
script written by myself on top, and then he continued writing after because he's not very good. He said probably said made some mistakes, right? So the Ambahan poet immediately saw that this is not the way to write it. They know, and we may be enamored. No, for example, all of us want to, these deconstruction, Derrida stuff like that. It's indeterminable the meaning. But no. In context, there are very great constraints in reading these kinds of texts, right? So it's not I think those ideas that, for example, this writing system is actually produces infinite meanings. It's random reading. It's Orientalist. That's an Orientalist way of looking at at our writing systems. That this is so strange. It doesn't really record anything, right? It's random. It's it's full of indeterminacy. They will say, but that comes from someone who doesn't really know how this writing system works. A Mangyan poet would say, no, that's not the right way to do it. I'll show you how to write it down, right? So there are many constraints which work within this writing system.
So in some sense, it's kind of like us looking back where this multiple meanings. No, it's because we're looking back without the context
Oh,
of
yes,
it.
that's one thing too. We
That's
lack the
why
context to actually fix it.
that's why we have all these. But its original use, they didn't actually think of these multiple meanings as kind of a or something, a goal of the language, diba? They were sure about what they were trying to say in some
Well,
sense.
not very sure, but more to an acceptable extent. They were trying to make. They were trying very hard to develop a writing system which could record their thoughts. Trying very hard. They were trying their best. You know? So it may not be perfect from our point of view today, but it is what they had, and it worked for them.
So, sorry, we're running out of time, but there are a few more questions from May Bowman. The DC was printed by woodblock, made presumably by Chinese craftsmen under the supervision of the Spanish friars. So can we suppose that those who carved the woodblocks were aware of how the text would work as printed for reading loud?
So it was, yeah, it was correct. It was printed using woodblocks. So it's a Chinese style of printing. Therefore, they probably had Chinese printers to produce it. And yeah, it's rather a mystery as a process of its production, and and how it was transcribed into how the Tagalog text, for example, was transcribed into Baybayin. And in my study, I also showed that the Tagalog text in 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 the Roman script is not exactly the same as the Baybayin, the one in Baybayin. There are divergences, and in some
Yeah.
cases, the Baybayin script is closer to the Spanish original than to the Tagalog script, to Tagalog version in Latin script. So the process of its production is something quite a mystery for us. But I would say that this is I would still dispute some statements that it was written by someone who didn't know anything about the Baybayin system. You know, if you look at how it was logically formed, and also look at the how it tries to stay within the 6.577 length of 7 segment length, it means that they were very much in tune with how it was working at the time. So I can't answer really all of the, what the background things about this. We have to explore more, or we have to do some more research probably to find answer many questions about it.
Two more. Sorry, is that okay, Bowman?
Yeah,
He
yeah.
says, oh, there was just a question about Basahan. Are there good resources about Basahan or the Bicol script? This is like the first question way up there from Marty.
Sorry, I'm not really. I've only looked at representations of the Bicol script um, in various tables of Philippine scripts, but I've actually never seen an actual script written in the Bicol script. And but in our book, um, in our discussion of the Tikao stones, these were stones found on the island of Masbate near Bicol. We had some. We were a bit puzzled because some of the characters pointed to Bicol Bicol language. It could be Bicol words, right? So given its nearness to the area, so we and had some relationship maybe with with that culture in Bicol. So it's still something that may be investigated, but I haven't really encountered any extended discussion of that particular writing system. Like many other Philippine writing systems, there are so very few samples that we can see that we have in the historical record.
Bowman, if anyone wants to play with a program, how will you be will they be able to access it?
Sorry. So you can, maybe Christina can give you my email. I think at the moment, I think they can communicate with you. Can they
Okay.
communicate with you? So they can ask for my email and I can send them the program. I'm still going to make it a bit more easier to read because it's rather uh, messy at the moment because I was writing it very quickly. So it's a kind of kludge, it's called a kludge when you write a program that's very messy. So I'm going to clean it up and then I'm going to send it to anyone who wants to use it. It's just, it can be used by anyone. Experiment or do anything you want. Unfortunately, I cannot send the Mangyan reading program because the Mangyan dictionary I'm using uh, is not yet cleared for public domain. So, which was written by Anton Postma, and it cannot be disseminated. So the
Right.
Mangyan dictionary, which allows you to read um, automatically Ambahan poetry, cannot be released to the public
Oh,
because it's still subject to negotiation whether it can be made public
oh,
domain. Sayang din, because I
mm,
think a lot of people also want to experiment with that,
mm,
but that dictionary is still uh, you know um, the property of the Mangyan community and can't
mm.
be released just like that.
Okay. And can the program also might be able to read Tagbanwa? Woman, no.
Yes. Yeah, I just need some. I just the problem is I don't have a Tagbanwa dictionary, but I
Ah,
do. I have a Mangyan dictionary because of Anton Postma.
ah,
Yeah, the great Anton Postma had
mm,
a because the language of the Ambahan is different from everyday Mangyan language. So even if you encode, for example, if you have a dictionary of everyday Mangyan speech, that won't let you read Ambahan because Ambahan is kind of uses an elevated and very ceremonial language,
mm,
very beautiful language. So when someone recites Ambahan poetry, they use a different vocabulary, which immediately marks it as Ambahan, as poetry. So Postma developed a dictionary for that, and that's why I could make the program work for it. But at the moment, I don't have a Tagbanwa dictionary, so I can't do it. Maybe someone who has a Tagbanwa dictionary can do it, so that we can have a complete. It can also be used, I think, for Bugis writing systems. But I have to contact my friends who are studying Bugis.
yeah, so it's key to have the I don't know the dictionary. We're
Yeah.
currently trying to transcribe a bamboo their inscriptions, but it's Tabanwa. Uh,
Mhm.
so yeah, and Myfel is I think Myfel is around. I'm not sure, but he's also trying to help us transcribe from the Cologne Museum. Uh, uh, they're trying to figure out the meaning. So are there? I think there. I don't see any other questions in the chat. Um, yeah. Any closing words, woman? Oh, wait,
Ah,
sorry. No, yeah. Oh, my
ah,
fell is here. Yeah. Oh,
I thought.
sorry. Maybe really. Sige, Bomen, closing
Okay.
words.
Maraming salamat, Christina. Thanks for everyone who listened, even though we had problems at the beginning with the internet connection. I was really it was really frustrating that because I was going to use a demonstrative program, and if we had problems with the internet, that would really be a disaster. So I'm glad it worked out, and thank you very
Yeah,
much,
yeah.
Christina. And I hope we can continue to work on these kinds of projects. I just want to announce that in November, we're going to have a digital humanities Philippine National Digital Humanities Conference, and I think we have it in, we've announced it in Facebook. So hopefully some of you who are listening today or tonight will try to join that conference. This is Digital Humanities, which I have demonstrated to you because it uses computers to interface, for example, the reading of poetry, right, and other kinds of texts. So thank you very much. Thank you for having me, and have a nice morning, day, Christina.
Yeah, and then also announcing we'll be having a workshop transcribing the Tagbanwa script from the Cologne Museum. So I'll announce, and maybe and then Myfel can also help. Will be our resource person. So yes, thank you very much.
Salamat.
Elsa is here. Bomen, May. Um, yeah, sorry for that kind of bad start, but I'm so happy it worked out. And we will have a recording. We'll try to edit out stuff and then put up, if that's okay with you, Bomen, for
Yes,
people
Roy.
who might want to ask. Yeah. So thank you very much. And
Thank you.
yes, thank you.